Hello, everyone, and welcome to today's webinar, How to Securely Configure a Linux Host to Run Containers. I'd like to introduce you to today's presenter, Kevin Lewis, the Solution Architect at Twistlock. Kevin spends his days helping organizations navigate the security challenges around containers and their migrations to DevOps. Before I hand it over, I want to encourage you to submit any questions you may have via the console. We'll answer questions at the end of the session, which should last about 30 minutes, so we should have time to answer a number of your questions. If we do not get to your question before we run out of time, we'll follow up with you directly after the event. We have also loaded a few attachments and made some links available in the console so you can access some related resources, and you can use those at any time. Again, thank you for joining us for How to Securely Configure a Linux Host to Run Containers. I now turn it over to Kevin Lewis.
Good morning, everybody. So my name is Kevin Lewis. I am a solution architect here at Twistlock. We are the leader in container security, and we were first to market and have been around for around 2 years now. I started my career in startups as a developer and moved to an engineering manager and finally into technical sales. And I'm an avid golfer. So we're going to go ahead and move right into a hands-on portion. This is mostly a hands-on demonstration of how to configure the host to run Docker. So I'm going to go ahead and move over to the screen share. There is a join me that you guys can join, and you'll be able to follow along as we go ahead and do this. Go ahead and start my screen share here. And so I'm going to go ahead and configure a CentOS machine today that's running on Google Cloud Platform. Of course, these techniques apply to any Linux distribution that you're using. The commands just might vary a little depending on if you're using Ubuntu or Debian. The package managers might be different, but the overall concepts apply regardless of which operating system you choose. So to start out, I'm going to install the tool here. It's called Nmap. Just do a yum install Nmap. And what Nmap does is it allows us to basically scan the host and see which services are listening on which ports, which is an important first step to securing your machine, is understanding what's actually running. You want to start with a minimal install of your operating system. If you're installing off of like a CD or you're installing off of a thumb drive or something like that, most Linux installations will have the option for a minimal install, and this removes things like development tools and other packages that you really don't need in a production environment that can actually be exploited by attackers should they compromise the host. So we have Nmap installed. Then I'm going to go ahead and update the packages here. This is an important first step in any Linux securing. You want to update the packages and dependencies in the operating system. This is one of the most common attack vectors is exploiting CVEs within the operating system packages or dependencies within your development libraries, such as Java jars or Python or Ruby gems and so forth. So making sure that you have up-to-date libraries, up-to-date versions of your packages helps to reduce that attack vector, reduce the amount of CVEs that you have available for exploit, and generally will help secure your box. So while this is finishing up here, we're going to open up to our first polling question that's going to ask you guys how far along within your Docker journey are you? Okay, this is just about done. It'll just take a minute to finish cleaning up here. Okay, and we are done. So far we've installed Nmap and we've updated our packages. The next thing you'll see that I'm running here is root. As you guys know, root has a lot of privileges and things that you can do within a machine. So a good practice is always to add another user to your machine. You're starting with a minimal install. Frequently the only user added would be a root user or maybe one you added during the install. So I'm just going to go ahead and do an add user. And I'm going to call him Docker user. I'll go ahead and set a default password for them. Okay, and then next thing I'm going to do is I'm going to add the Docker user to the wheel group. And what this does is gives the Docker user the ability to run sudo commands. And sudo is basically a way to elevate the privileges of a user on a one-time basis. So if I wanted to run a command that would normally require root or elevated privileges, I can do it as this user. So I'll go ahead and change over to the Docker user, and I'll use the Docker user for the rest of the configuration. So at this point, what I would do if I was running a new box, I would go ahead and configure the SSH daemon. In the case of Google Cloud and some of the other cloud providers, some of this securing has actually already been done. But I want to point it out where you would go to do this in case you are configuring, from a default install. This is something that you would want to do. So we'll edit our SSH config, and the first thing, first thing we're going to search for is permit root login. We'll find it here that you'll see on this Google machine that's actually already set to no. This would normally be set to yes, and you want to disable root login. So if your root credentials get compromised or somebody is using some kind of login using root, this would deny that. So they would have to have some other kind of user credentials to log into the machine. The second thing you'd want to do is disable password authentication. So we'll search for that here. We'll see here that we set the password authentication to no. And what you're doing here is you're removing the ability for username and password combinations to SSH into the machine and enforcing users to have secure certificates to authenticate. What this does is, first, they have to have a certificate, and second, it removes the ability for brute force attacks. And a lot of times, machines get compromised from the simplest things. It isn't necessarily some convoluted exploit in an application you're running, but just default credentials. Someone has admin password as their username and password combination, and a brute force attack exposes that and gives people access to the machine. So by denying root logins and enforcing certificates for authentication, you can remove those as attack vectors. So after I change those, I would want to use system control here, and I would restart my SSH service. And and there's one other step that you would actually do here if you were configuring this, and that is to generate these certificates for your user and update them and upload them to the box rather, so that you can use them for authentication going forward. So we've updated our packages, we've added in a user, we've secured our SSH daemon. And so the next thing you want to do is you want to take a look at what's running on the box. What are the services that are running by default? And so just understanding the topology of the box, what's running, what's listening, and that's why we installed the nmap utility here. I'm going to go ahead and run nmap here. It's going to do a quick scan of the host to show me what services are listening on which ports. And here we have SSH listening, SMTP, and NTP for time synchronization. And normally I would probably disable everything but SSH and NTP. But for the sake of the demonstration today, I'm just going to stop and remove postfix, which comes running default in CentOS. So first thing, we'll do a sudo system control, and we're going to stop the service. And I'll just run nmap here again just to verify that SMTP is no longer running. Okay. We see here that we're no longer listening on port 25. And since I'm not going to be using it, I'm actually going to go ahead and just remove it from the system. Okay, so now we've removed postfix, and this is a similar process you'd follow for any of the other services that we're listening if you wanted to disable NTP or any of the other services that are running. Very similar process, just swap out the package names and service names. Okay, so we've stopped the services, secured our SSH daemon, and now would be the time where we install Docker. So by default here, Docker repository is not added to the package manager. So what I'm going to do is I'm going to add in the Docker repo for Yum. Just go ahead and edit this here. And I'm going to copy and paste something here. And this is all available within the slide deck, so you don't have to try and copy it down from the screen share here. And so I've added in the repository information here. And then I'm going to ask Yum to go ahead and install our Docker engine. It'll just take a minute to finish installing the packages here. Okay, so our Docker engine is now installed. We're going to do just going to go ahead and start the Docker service. So Docker should be up and running now. And we're just going to do a quick test. The default test is just to do a Docker run and run the hello world. So we'll go ahead and do that. It's going to pull the image and run it. We'll see our hello message from Docker. So Docker is up and running. And the next thing you want to do is make sure that Docker is started by default as a service when the machines are restarted, whether it's for patching or other reasons. So we'll use our check the pig, Docker on. And now we've go ahead and set Docker up to restart each time we go ahead and start. So we've got Docker all installed. We've started to configure our host for security, and we have to add in some commands to Docker, so command line operands to Docker to give it some sane defaults. So we can do that here. I'm just going to sudo. We're going to edit our user lib. Docker service here. I'm going to go down to the line here, the exec start. I'm going to add in a few commands here. So first, we're going to add in ICC equals false. And what this is doing is this is saying, inter-container communication is disabled. So this will prevent containers from talking to each other on the overlay network and communicating with each other in general. And this is a good practice to make sure that if a container is compromised, it's not being used as an attack vector for, an east-west attack or anything like that. And to have the containers actually communicate with each other, they should have service endpoints or, a DNS entry that can be used to reference the external port of the container rather than trying to do internal Docker communication or internal container communication rather. We want to set our log level equal to info. We don't need the debug logs unless we're trying to troubleshoot something, but we want enough logging information to, if something does go wrong, we have at least enough information in the log to be able to diagnose what's going on, where do we need to look, and so forth. So info is a good level for that. We're going to set IP tables equal to true. So Docker is actually able to manage IP tables for you. In a secure environment, you want to have your firewall exposing only ports that are absolutely needed. So in our case, we would just have SSH port 22 enabled. And as you deploy containers, things like Nginx or your MySQL server, whatever you happen to be running, you're going to need to expose those ports, but you only want the ports exposed when the containers are actually running. So by adding this flag to Docker, we allow Docker to manage our IP tables firewall rules and open and close ports as it's needed and as services are exposed. Next thing we're going to do, we're going to add in some default limits here. So our default ulimit, we're going to set the number of processes here to 2048. And we're going to set another ulimit here. Number of file handles. So And, these are just examples and values that I find are good to start with. You may have to add or resize these depending on what's needed for your environment. But these are good, sane defaults to start with. And the final thing we're going to do is we're going to disable our legacy registry. And so what this does is this it disables the ability for Docker to reach out to older insecure registries, making sure that you're using a Docker v2 compliant registry with authentication. So we've added in our defaults here. Go ahead and save that. And then we're going to restart our Docker engine. Okay, then we'll do a sudo service. Let's go ahead and take a look. Probably a little typo in some of my command lines here. So our ICC false, our log level is set to info, IP tables is true, default ulimit and false. Default ulimit is 2020. It's true. Take a second to troubleshoot and see if we had our problem here. Oops. Simple typo there, caused some issues there. So, all right, so we'll go ahead and correct that, and we'll go ahead and reload this and do a sudo service. Okay, so we just had a little typo in some of our command line parameters there. We've corrected that, and we've restarted our Docker engine. So we'll go ahead and do a PSEAF, and we're going to grep for Docker. Take a look, and it will show the new command line parameters that we've added to make sure that it's configured in the way that we want it. It looks like we're doing well there. So for CentOS, by default, we're using firewall D. So I'm going to go ahead and just disable firewall D. And I'm going to install our IP table services here. These are just some helpful utilities when using IP tables. And then we would set that we want to enable IP tables. So go ahead and do that, and IP table is now enabled. And so here you'd add in some basic firewall rules. I'll just add in a couple here. Our IP tables. And then I would also put in one more rule here. That would enable our SSH daemon over certain ports. So we'll go ahead and we'd put in our server IP here, give it the source ports 513 to 6535 here, and our destination port of 22. And so this example here, basically what we're doing is we're dropping input, dropping forward, and then we would enable only the TCP access for port 22 and SSH. So from here, since we have our IP tables command line in, added to Docker, from here as we expose new containers and new ports, Docker will go ahead and manage all of that. So we're going to do a simple test here. We're just going to do a Docker pull of Nginx. Go ahead and have that pull that image, and then we'll do a sudo docker run. And we have our Nginx container up and running here. And we'll go ahead, open a new window here. And connect to our Nginx server. So, just kind of a recap of what we've done here today. We installed Nmap. We went through and updated all of our libraries and dependencies on the operating system. We added in a new user that can be used for, normal day-to-day configuration. We configured our SSH daemon to not allow root login, to disable password authentication and force people to use certificates to connect. We've disabled any extra running services that we don't explicitly need for the applications that we're running. We installed Docker and got our Docker engine up and running. We configured some same command line defaults for Docker. We did a little troubleshooting on those, and so if you have an issue, there's an example there of how to go ahead and correct them. And then finally, we restarted our Docker engine, configured our IP tables, and did a test with Nginx. So I hope this was helpful in showing you guys, the basic configuration and hardening of a machine to set up and run Docker containers. And with that, I will stop the share here, and we will move back to Jared.
Hi, thanks, Kevin. Yeah, that was great that we could go through that. There were a couple questions that came in during that time, so I was going to see if we can bring this to you. One was, does Docker install SELinux? It appeared to do that in your YUM, so I was wondering if you could clarify that a little bit more. More
sure. So Docker does make use of SELinux. It's actually an option that you can have turned on or off. It installed it here, but I actually didn't enable it. There are some steps and things that you can do for further Docker configuration. One of those things is to ask Docker to use AppArmor and SELinux. Those are certainly steps that you want to do if you're making use of those technologies. But by default, it installs, but it's not actually running in your Docker engine. You'd actually have to add that as another one of the command line operands.
Great. Thanks, Kevin. One other thing that came in, what are some other kind of considerations that you might have for securing your container environment?
Sure. So some of the things that you can do, and this starts to venture into some of the things that Twistlock does. And so there's a CIS Docker benchmark, which the Docker benchmarks are basically their suggestions on how to configure and run a secure Docker environment. And these things apply to the host, the Docker daemon, the containers, and images. And so there's different things, like, for instance, one of these compliance checks might be don't allow your containers to run as root. Another compliance check might be, make sure that your Docker engine has a separate partition configured for the Docker images. And so kind of the next step forward with that is to look at the CIS compliance, make sure that you're auditing your Docker daemon, making sure that your containers and your images are configured properly so they won't run as root, won't run as privileged containers, and so forth. So past the host, there are plenty of things that you can do around your Docker daemon, as well as the images and containers. And it's the combination of those four things that when you start doing all of those things, you have a truly secure Docker environment. So definitely concentrating on the host is a great first step, but there are some things you need to do further down the road as you actually start running images and containers in your environment.
Thanks, Kevin. I just had a question come in. Would the steps be different for Ubuntu?
So the steps would be, overall at a high level conceptually, the steps are going to be the same. You're going to want to do a lot of the same things. You definitely update your packages. You're going to want to modify your SSH daemon, for the different types of logins. Definitely configure IP tables and install your Docker daemon. And so these steps would be different just based on a syntactical nature, but from a contextual nature, they're actually going to be very similar in the things that you want to do to secure any of these hosts.
Great, thank you. So we're running up to the 10:30. So just as a housekeeping, I noticed a number of you have been accessing the attachments. We will be updating the slide deck and making that available to you all and have that available to you. So expect to receive an email from us in the next day or so that will give full links to the presentation as well as some other assets, as well as a link back to this webinar if you want to replay it. So that's, as we're coming up to the top of the half hour, let's wrap it up here. And if you have any questions or you want to learn more, you can head over to SwissLock.com. You can explore what our product does and how it helps, as Kevin mentioned, kind of bring an additional layer of security into your container environments. And we do have developer and enterprise licenses available. You can complete the form there, developer edition free, and we can do evaluations for our enterprise edition. So thank you all for your time today. We look forward to connecting with you all in the future. Thank you.